OHSOME Building COVID-19 Extraction. In this second course of Python and VGI, you will learn to visualize extracted data of OSM on a map. Let's begin by importing the essential libraries. The OHSOME client library is used to access the OHSOME API for retrieving OpenStreetMap data, while matplotlib pyplot enables the visualization of this data to reveal spatial patterns and distributions. Next, initialize the OHSOME client. This step sets up the client for sending requests to the OHSOME API and receiving data in return. Building extraction. To extract data on buildings, first specify the area of interest with bounding box coordinates. These coordinates define a rectangular area in Bochum-Querenburg, ensuring that the data extraction is focused on a specific location. Set the date for the data retrieval. Specifying July 1st, 2021 ensures that the data reflects the situation on that particular day, providing a snapshot in time. Here, we define a filter to focus on building features. The filter targets all building features and their outlines. Applying this filter helps in narrowing down the data to only the relevant types, making the dataset more manageable. Now, send a request to the OHSOME API to retrieve the building data. By using the response variable, a request is sent to the API to obtain building data for a specified area and date. This request includes the defined filter to refine the results. With this function, we convert the response data into a data frame for easier analysis. Converting the API response into a data frame allows for efficient data manipulation and provides an initial view of the dataset by displaying the first few rows. To visualize the building data and gain insights into spatial patterns, let's create a plot. The plot displays the buildings in Bochum-Querenburg, with red markers highlighting their locations. Visualization helps in understanding the distribution and density of buildings within the area. You can save the visualized data to a GeoJSON file for future reference. Saving the data in GeoJSON format ensures that it can be easily accessed and used later for further analysis or sharing. COVID-19 vaccination center extraction. For identifying COVID-19 vaccination centers, start by defining a larger area of interest. These coordinates outline a broad region across Germany, enabling the extraction of vaccination center data on a national scale. Now, set the date for the data retrieval to ensure consistency. This date aligns with the previous data extraction, maintaining uniformity in the dataset. Here, a filter is applied to focus on COVID-19 vaccination centers. The filter selects nodes representing vaccination centers. This targeted approach ensures that only relevant data is retrieved. Request the vaccination center data from the API by setting the variable response and giving it some parameters. Using the response variable, a request is sent to retrieve vaccination center data for the specified area and date. This request is filtered to include only COVID-19 vaccination centers. Now, convert the response data into a data frame. Now that we have a data frame with vaccination centers, we can easily examine and manipulate the data if needed. But for understanding our data frame better, let's create a plot to visualize the vaccination centers. The plot visualizes the locations of vaccination centers across Germany, using red markers to indicate their positions. This visualization aids in understanding the distribution of vaccination sites in Germany. This can be valuable in multiple scenarios, e.g. for avoiding an oversaturation of vaccination centers in one specified area. Finally, save the vaccination center data to a GeoJSON file. Saving the data in GeoJSON format ensures it is preserved and accessible for future analysis or reference.